Salam alaikum. Good evening to you all. On behalf of ISACA Muscat chapter, I am very happy to welcome you to our webinars. Today's webinar will be presented by Mr. Abhay Bhargav. Abhay Bhargav is the CEO of V45. This company is mainly focusing on application security. He is the chief architect of Orchestron, a leading application vulnerability correction and orchestration framework. He has created some pioneering work in the area of DevSecOps and AppSec automation, including the world's first hands-on training on DevSecOps that is focused on application security automation. And he is also the chief architect of Orchestron, which is a DevOps first vulnerability correlation and management application. He is a well-known speaker on many industry events, including DevCon, Black Hat, OWASP, AppSec ACA, EU, and AppSec Cali. These traits are almost very hot. It have been sold events at conferences in many places from USA, EU, Melbourne, and places. On behalf of all of you, I welcome Abhay to give the session, and I'm happy to hand this to Abhay. Abhay, please take over. Thank you very much.
All right. Thank you, Mr. Mari, and good evening to all of you. In fact, it's a very interesting experience for me to be back at ISACA Muscat speaking. Of course, one of my early talks on several application security subjects was at ISACA Muscat. So I come back to all of you with a lot of fond memories of not just that talk, but also of the chapter in Muscat and many of those people many of them who I've still had either personal or business relationships with. So it's been it's very nice to come back and speak at the ISACA Muscat chapter. I hope I am audible to most of you. I'm not sure if I don't know whether you have access to chat. Okay,
you are audible.
Yeah. Perfect. So I'm going to get started in that case. And today's topic that I'm going to be speaking on, let me just minimize the GoToMeeting thing. So today's topic that I'm going to be talking about is one of my favorite topics. It's been a topic that has been a major research area of mine for the last about 3 years or more than that, about maybe 4 years now. And this is something that I am sure a lot of you in the industry have heard of. Right, so most of you have started, you would have heard of this topic, at least one part of this topic, which is DevSecOps. The term DevSecOps, I'm sure, stands out in all of your minds as something that is suddenly becoming a very important thing. Everybody seems to be talking about it. Everybody seems to be thinking about how they can do this. Some of you might even have CTOs and CISOs that are requiring you to do this now, and this is something that has become a desperate need, and in my opinion it's a need that is absolutely essential, that is coming up at probably the right time as we go into the next frontier of application development. So today I'm going to be talking about a practical view of DevSecOps pipelines. I'm going to take you through in the next maybe 2 hours or so, maybe a little less than that, hopefully, on all of these different areas and topics. We'll also look at a bunch of demos and so on. So let's get started. First of all, I thank you for the introduction. I have this slide, so I'm just going to finish this up. So my name is Abhay, and I'm sure some of you I have already spoken to, so some of you already know me. But I run a company called V45. Now, V45 is headquartered in the US and India, and we are also now in Canada and EU. So we are largely an application security company. So we work on anything related to application security, right? So one of the first things we started doing was we started off pen testing and doing application security services and so on. But over time, we have started to move with the industry. We've started to re-energize industry trends in the form of things like DevSecOps or threat modeling, and especially cloud security. So some of you who are working on cloud projects or maybe working on cloud projects shortly, cloud security is one of our major focus areas. We do a lot of work in the cloud. Aside from our work with clients, we also contribute a lot to open source. So three of our projects, as you can see here. One is called Orchestron. We have both a commercial and a open source variant. This is a vulnerability correlation platform. We have another tool called Threat Playbook, which is a threat modeling as code automated threat modeling platform, which is also quite an interesting. Probably I'll speak about it another time to ISACA Muscat, but this is another major area that is emerging as an important aspect of security, especially moving forward. And around cloud security, we are extremely heavily entrenched in the process of doing serverless security. So a lot of our work in this is culminated in this project called DV-FAST, or Damn Vulnerable Functions as a Service. So that's some of our projects that we have open source. I would encourage them, some of you, to check it out, and if you're interested, contribute to it. Check it out at least at the very least. Aside from that, I do a lot of training. In fact, I've trained at Black Hat, I've trained at DEF CON, I've trained at some of the world's largest events. I do a lot of coding myself. I pretty much write code every day, especially around automation and so on. So that's something that I do. This is, some of the trainings and talks that I'm going to be doing over the next few months. So I'm going to be training at Black Hat. I'm going to be speaking at SecApp Dev in Belgium next week. Echo Party in Argentina later in the year. Hack in the Box. OWASP. We are a regular fixture at OWASP. So if you are in any of these events, do say hi to us. I'll be happy to talk about anything that we do and anything that you are interested in talking about as well, especially related to application security. So I look forward to hopefully meeting some of you there in some of these events as we go along. Now, one of the things that I always have in my presentations is live demos. I don't do recorded demos like a lot of other speakers do. I do live demos. And when I do live demos, there is always a risk of something going terribly wrong. So, which is why I always pray to the demo gods. So I'm going to invoke a small prayer to the demo gods, and hopefully everything should go well, especially with the live demos that I'm going to show you. So hopefully some of the demos are interesting, and you might find that it resonates with some of the things that you are doing. So let's, I always invoke this before we get started. Now, before I get deep into the subject itself, I just want to quickly explore a little bit of history. Right now, history is always one of the best teachers that we have. And I want to explore a little bit of history around how we got here, what made DevSecOps such an important thing. I'm not sure how many of you are doing DevSecOps, but you would see that worldwide it's become an extremely important trend. And in fact, in Dubai as well, where we work with a lot of companies in the Middle East, we see that there is a lot of requirements for DevSecOps and need for DevSecOps moving forward. So let's see what got us here. What is the history behind DevSecOps, so to speak? So really, the history of DevSecOps kind of emerges from manufacturing, right? In fact, the history of agile development itself. Now, many of you might have heard of the term agile software engineering or agile software development. Now, all of these things really came from engineering or from manufacturing in the true sense of the term, right? So manufacturing really, in manufacturing, there is a very important book called The Goal by Eliyahu Goldratt. Now, this book essentially is a treatise on how to streamline a manufacturing process by eliminating bottlenecks, right? Now, I'm not going to give up too much of the book because the focus is not the book, but this really was one of those foundational concepts that was applied to Agile, right? So previously we had a certain way of delivering and developing applications. It clearly was not working. So the world kind of evolved into this process called Agile, where things happen iteratively, things happen faster, things happen at much rapid paces and scales than it ever would before. So really, a lot of the origins of Agile and DevSecOps or DevOps itself comes from Agile, right? So let's talk a little bit about that. Now, I'm sure some of you have seen this diagram, and some of you might have even might still be using some aspects of this diagram within your own workplace. Now, this is what you would typically call a waterfall model, right? Now, a waterfall model is a very well-known precept of software engineering where everything happens sequentially, right? Now, you first do the requirements analysis or systems engineering, you gather the requirements and you create a requirements document. Then once that is done, you create a design of that particular requirements document. Once that is done, you write the code. Once the code is fully done, you start testing. Once testing is completely done, then you deploy the application to production or wherever it is that you need to deploy. Now, this sounds great, and this, in fact, sounds like a very perfect, sequential, straightforward plan. But in reality, this plan was a nightmare, right? In most cases, what happened was that you started on this process, and since everything was sequential, you would take a year, 6 months, 8 months, 2 years sometimes implementing a project. And once you are done implementing it, the customer or the internal stakeholders would be like, hey, this is not what we wanted. We wanted something completely different. What have you given us, right? So the waterfall model did not really allow for changes, did not allow for iteration. And in business, there is always iteration, and iteration is the name of the game. And this model just was not working. So, which is why we started creating, our group of enlightened software developers came up with the Agile Manifesto, which essentially said that focus on individuals and interactions over processes and tools, working software over comprehensive documentation, which is also one of the precepts of the Agile Manifesto, customer collaboration over contract negotiation, and responding to change over following a plan. So essentially, all of these 4 statements were oriented towards the fact that, hey, we need to build software in a more iterative way. We need to build software in a way that it works, rather than focusing extensively on amazing looking documents or beautiful looking documents and treatises on how this is supposed to work, and focus on collaboration and iterative building rather than negotiating over over time and material and so on and so forth. So really responding to the changes in the business rather than having a set pattern that nobody wants at the end of 2 years. So the Agile Manifesto changed software development in a very, very seminal way, right? Excuse me. Agile really made sure that software became, in fact, even today, I'm sure if many of you follow Agile methodology, you will see that there is a lot of iterative nature of an Agile team. So the Agile team is a much more collaborative team. It's a much more, it's a much more iterative driven team. So tomorrow, let's say you're running an insurance company, and that insurance company has a new requirement that comes in for a particular application. You can address that without having to break your plan. It's part of the process. So iteration is part of the process. So that's one of the big things with Agile. Now, one of the things that Agile did was it kind of launched a bunch of movements without a lot of us noticing at all, right? Now, Agile increased velocity, right? And when I say velocity, Agile increased the speed of delivery of applications. Now, Agile, what it did was since you started building iterative products, we started realizing that, hey, this iterative stuff is pretty good. We can go faster. The UI that would take 6 months now can take less than a month. We can release this in less than a month and then figure out how it works, and then make some changes, release it next week, or release it in 2 weeks, or release it in 3 weeks, or release it the same day. In fact, I don't know how many of you know this, but Microsoft deploys code 87,000 times a day, which is I am sure you will realize that that's a massive number. It releases code to production 87,000 times a day, which is a staggering number. So Agile, one of the things that Agile did was that it increased velocity, and it increased velocity in a very, very meaningful way, because people started going faster. You wanted applications delivered faster, so people started going faster. And since there was already this focus towards iteration, people started building things faster, which led to better engineering tools, better frameworks, better products, better UI frameworks, simpler frameworks. All of these things really came about once Agile kind of came to the fore. I see that as a watershed moment in software delivery history, so to speak, right? So you look at some of the things that Agile did. First of all, it moved away from monolithic apps, right? Now, I'm sure some of you in this room have dealt with monolithic apps or still deal with monolithic apps within your organization. So one of the big things that happened was that, so previously you used to build this one big app, right? You would have this web application or any other application that you will, let's say an SAP or whatever it is. It would be this one large application that you would constantly add features to this application, right? Imagine this one big building or one big chunk of rock like you see on screen here, and you're constantly adding features to that, you're constantly adding capabilities, removing capabilities. Now imagine having to scale this big piece of rock. Imagine having to distribute this across millions of users in the world. You would have to scale horizontally, deploy it on servers. It would become a big problem. It would be a huge scalability bottleneck for your organization. So this becomes a huge challenge once you start to deploy this. Maintaining it is hard. So let's say the developers who are working on this move on to another job, then you are stuck because you're stuck with this huge application that nobody knows how to do or nobody knows how to work with. So maintainability is a problem. Fault tolerance is a problem. Security is also a problem because remember, when you fix something, something else breaks. And so when you fix some security bug, you may not have been able to fix a security bug in several other places. So monolithic apps tended to be a little hard to do, which is why the world, especially especially over the recent 5 or 6 years, or even close to 10 years now, has really started moving over to microservices, right? Now, if you look at any major tech company today, you look at Google, you look at Facebook, you look at Uber, you look at even not just major, even minor or even mid-sized technology companies, they all want to build smaller services, smaller, more fault tolerant, more easily maintainable services. So that's becoming a big thing, that a big movement, and they do that because they want speed, right? So one service, a team that's building one service can be completely independent of a team that's building another service without having to compromise quality, without having to compromise without having to compromise the overall process itself. So if you look at Uber, for instance, this is something, this is a small representation of what Uber's microservices stack looks like. So they have one passenger management microservice, they might have a billing microservice, they might have a driver microservice, trip management microservice, and all of this is connected through meshes and so on and so forth. So this is becoming the new norm, and this is making sure that software is built faster and delivered faster, right? Uber is not going to sit around waiting for 6 months to release a new feature. It releases features every week, probably every day, multiple times a day. So obviously, it's not going to be able to wait for that long without doing something like this. The other thing that also happened because of Agile is move towards simple frameworks, right? Today, instead of writing, more object or more standard code or plain Java code, you're writing a lot of framework-based code. Now, frameworks give you all of the necessary plumbing and all of the necessary piping that ensures that you can go faster and build your applications faster and deploy them faster and so on and so forth. So this has become a major movement that has happened today. So once Agile came, you've seen that frameworks have come, and frameworks have made it faster and faster for developers to build and deploy applications on any environment that you want. So you have better development tools, you have better deployment tools, you have better source control tools, you have the cloud, of course, which has been a huge contributor to all of this. So all of this has happened, right? You've seen a massive amount of change that has contributed to speed, and speed has increased exponentially because of all of these things, especially fueled by Agile, right? You've seen infrastructure as code. Now, whenever you want to deploy stuff today, you don't really need to ever type some commands on a Linux machine. You can just write them up as scripts and deploy them on Kubernetes or cloud or wherever, what have you, right? So for instance, I have not done any kind of deployments, manual deployments myself over the last 3 years. I've only written code that would deploy things for me and manage the state for me. So this has become a huge kind of thing, right? So as a result, all of this has led to more automation, right? Now, obviously, if Microsoft is deploying 87,000 times a day, they can't do it manually. You can't have one whole team of people just deploying code or checking things and making sure that things are validated. You need to embrace automation, right? Especially at a time where talented humans are in high demand and less supply. You have to embrace automation. Automation is the name of the game, and that is why you are seeing the rise of DevOps, right? So DevOps is essentially a movement where dev and operations, so developers and operations have come together to create a harmony between the development and deployment aspects of your application, which means that a lot of what you're doing in today's modern application delivery is delivering things fast because you're doing a lot of these things automated. So all of this thing that you used to do manually, or some of it that you used to do manually, today has become automated quite comprehensively as part of your DevOps pipeline, right? So some of you may be familiar with this, some of you may not, but the idea here is that automation is the name of the game. Automation is where the world is going, especially when it comes to delivering apps. So we're doing all of this automation. We're seeing all of these gains, especially when it comes to automation. We are doing amazing things in the world and when it comes to automation. However, we have forgotten our extremely important consideration, which is security. What about security? What do we do about security? And this is where security becomes the next big bottleneck. So previously we had the process as the bottleneck. We might have had development as the bottleneck. We might have had ops as the bottleneck. But after DevOps, today, if you want to do things securely, that has become the next bottleneck. So you're doing all these automated things, but at the end of that cycle, you see that, hey, who has validated this? Has someone looked at the code? Has someone tested this application for security? Has someone validated that certificate that's been deployed? If the answer to those questions are maybe or no, it means that probably you're avoiding or completely ignoring security as part of your DevOps pipeline, which means that your application delivery is moving extremely fast, whereas your application security is lagging behind quite a bit. And in fact, is completely unable to keep pace with your application delivery. So your application delivery is running across sprinting across the mile line, but your application security team is still struggling to catch up. It's struggling to catch up. And this is something that we've seen. I've consulted with large organizations, small organizations. We build solutions for large and small and medium size. And this is a very common story across a lot of these organizations until they embrace automation for security. So what we need is first to find security bugs early and often, right? Now, once you, in fact, I think there was a statistic that was released that it takes about 200 days to fix a high severity security flaw once it makes its way to production. So imagine 200 days, a vulnerable app that is sitting out there in production, waiting for somebody to exploit it. So what we want to do is find security bugs early and often. Now, some of you might have heard of the term shift left. Now, this is essentially what shift left means. It means that you want to be able to find these security flaws as early as possible in the development cycle rather than later or once it goes to production, right? The next thing you want to do is integrate security with your agile development. You want to be able to move with the agile team rather than moving outside of the agile team. You want to be integrated into the agile team rather than seeing it as a separate security team or a separate security group. And you want security to work automated as part of your DevOps pipeline. And that's really what you want to do. So we are seeing that dev is already consuming ops. We are likely to see that security is going to become the next target. So security has to integrate and not create more friction and not create more bottlenecks. So if we want security to keep pace, you want speed and you want agility for your security, which is why security automation is so very important. So I train on this all the time, and security automation is extremely critical to what you're going to be doing, especially with security. So the idea here is that instead of doing these big efforts, so let's say you do a security review in Jan, and then you do another security review in September, which causes you to accumulate so much of activities of security. Do security continuously with some automation built in, so that you are making this a much more seamless and much more standardized process that becomes a part of your SDLC. It becomes a part of your software development lifecycle. So that's something that you should be doing with security. So when it comes to security in DevOps or DevSecOps, this is what a typical activity plan looks like. So DevOps has all of these phases. It has plan, code, build, test, release, deploy, operate, and monitor. And you have activities relating to security on the lower quadrant here, right? So you see that the upper quadrant, you see all of these DevOps activities. And in the lower part, you see threat modeling being done in the planning phase, static analysis and security composition analysis being done in the build stage and the coding stage. Once it goes to a test environment, that's when you run your automated tools to identify vulnerabilities. Once it's deployed to a staging or some similar environment, you run security automation to identify flaws with the operating system or the deployment itself. And once you deploy this to prod, that's when you need to look for your monitoring and detect attack patterns and so on and so forth being detected in this part of the pipeline. So you see that instead of doing security here at the end of the pipeline, you are embedding security at every single checkpost in that particular pipeline, right? So as a result, you have less pressure to do security at the end, right? I'm sure many of you who are doing pen testing for your companies or who have been part of pen test projects, where you'll have a scenario where your engineering manager will come to you 2 days before the release and say, hey, you know what, please pen test this and tell us what are the security flaws. You have 2 days to pen test this huge application. Then you come back to him and say, you know what, I found SQL injection, I found cross-site scripting, I found this, I found that, I found all of these flaws. Now, this is a problem because you've done the security assessment only at the last stage of the deployment, just before deployment. Now, here you have left that team with only two options, and they've left you with two options as well. One is to either go ahead and release and file a risk acceptance, which is a horrible thing, or you could have a scenario where they say that, look, we're going to fix this in the next release, and or they're going to delay the release and then fix it and come back, which is also not a good outcome because your product gets delayed. So one of the things you should be doing is embedding security across all your processes so that you can find security bugs as early as possible. In fact, if you find security bugs in the first two stages, you are much better off than having to find security bugs later on in your cycle. So one of the things you have to look at. So we're going to look at some automation approaches for all of these different areas. So yeah, so essentially DevSecOps is essentially what the SDL should have been, right? This is what we've been saying throughout. If you are in security, you've been saying this quite a while yourself. This is what you are saying throughout. It's not a end process. It's not a gatekeeper process. It is a embedded process. So that's the idea behind DevSecOps. And that's really what DevSecOps is all about. So in this talk, I'm going to be looking at three phases of the DevSecOps pipeline. And I'm going to be talking about some approaches to doing security in that pipe, in those processes, right? So I still have 90 minutes, so I think we should be good enough to cover a lot of these things in that time. So the first thing that we're going to be looking at is pre-commit and commit time security. Now, this is when the developer is writing code and committing that code to a source repository. Let's say you have a Git or an internal, let's say you have a GitHub or an internal Git server or some other type of source control mechanism. I'm sure you have something in your organization to do that. So that's something that we'll be looking at in pre-commit and commit time security. So here you really have three environments, right? One is, of course, your developer's laptop or your developer's workstation itself. The next thing is once the developer commits it to a repository, and you may also have a service that automates your unit tests, your other integration tests and so on, which is also called your continuous integration service. So your developer environment, you can have security checks in the developer environment itself. You can have security checks built into GitHub or any other source control server that you're using, or you can have automated security checks being done as part of continuous integration. Now, remember, if again, earlier the better. If you can find more security flaws here, that's great because the developer can find it and fix it then and there. You don't have to worry about it. And you'll still be fine doing it here, but remember, earlier is always better when it comes to security findings, especially when it comes to DevSecOps related security findings. So let's look at some of the approaches we're going to use. We're going to look at static code analysis and look at how people run automated static code analysis in the wild. We're also going to be looking at source composition analysis. Now, source composition analysis has become probably the most important aspect of security today, right? Now, source composition analysis is the analysis of security of third-party libraries. Now, whenever you write code, and I'm sure if you're a developer or you're working with developers, you'll know this, is that developers don't write original code all the time, right? They import a bunch of libraries, they import a bunch of third-party tools, they use third-party libraries in their code. So to make an HTTP request, they might use a third-party library. To render a certain component on screen, they might use a third-party library. Now remember that these third-party libraries have been written by developers just like them or just like you and me. Now, when that happens, these developers may also introduce security flaws in that third-party library, in that library that they've built. And when that gets compromised, your application could also get compromised. So that has become a singular bugbear in the security product world, because a lot of folks don't even know anything about this. They are still kind of completely unaware about how to handle this, how to do this, and this has become a huge challenge in the security community at large. So let's look at this as we go along. So we're going to start off with static analysis, and we're going to look at static application security testing. Now, static analysis is really the practice of identifying flaws in the source code, right? Now, this is typically run against the source code or the binary of that particular application to be able to identify security flaws in that binary, right? So, for instance, let me show you a quick demo as to what I'm talking about. Now, I have a small tool here called Bandit, and I'm going to scan I'm going to scan my source code with Bandit. So what this is going to do is it's essentially going to scan some source code. I'm going to scan this particular directory. So I'm just going to scan it here. And essentially what I'm doing is I'm using a tool to scan this particular directory and this particular directory is full of Python source code files, right? So what it's doing is that it's going to recursively walk through all of the files and scan for security issues and come back with some results. So you'll see that it's going to run for a few minutes or sometimes even a few seconds, and you'll see that within a few seconds you should have some results dumped on screen. Now the idea here is that you should be able to find a lot of security flaws by just scanning your source code directly as part of the process. And I'll also be showing you some demos as to how you can run this automated, right? So that's something that we're going to be looking at as well. So that is essentially static application security testing, or what you would call code review, right? Or security code review. Now, the only difference between a manual security code review and an automated security code review is that you have a tool running an automated security code review. So you see that it scanned 4,600 lines of code and it came up with all of these flaws. So it came up with it came up with a SQL injection flaw in multiple places. It came up with a deserialization flaw. So imagine that you are able to automate this process even in the developer's machine itself. If you're able to automate this process, you will see that the developer is able to find these flaws really early in the cycle and immediately start fixing them, right? So the developer finds these flaws, the developer is able to immediately fix them and deal with them even before they become a problem once the application goes to production. So it's really like preempting security issues even before they can happen, right? So this is a very, very effective process. There are different, of course, there are some criticisms, there are some opportunities, but this is quite an effective process to be able to identify security issues, especially with the tools or the different types of tools that you use. So static analysis really is a very important practice that can be done as soon as the developer starts writing code. In fact, there are static analysis tools that you can install in the developer's IDE itself, and as the developer is writing code, it will start telling the developer that there are these security flaws in your application. So it actually behaves as a real-time feedback for our developers. Now, one of the things that I'm going to be using a lot in this talk, the term feedback. Now, what we want to do is to constantly introduce more and more security feedback without causing disruption. Now, remember, when we do a standard pen test, we cause disruption, right? Because we're giving feedback once in 3 months or once in 6 months or once in a year, and by the time it's too late. But what we want to do is have a system of giving automated continuous feedback that is high fidelity and does not have too much intrusive effect on the developers and the overall engineering team. We have to treat the developers and engineering teams as a customer and not as an internal teammate. We have to treat them as a customer for this to be able to succeed, right? So that's something that we'll see. So when we're running static analysis, there are different approaches to doing this in a DevSecOps pipeline. Now, one of the approaches is to use continuous integration. Now, with continuous integration, what happens is you have this one service like Jenkins or some other continuous integration service. Now, as soon as the developer commits code to your application, what you're going to do is you're going to run some scanning tools, identify security issues, and immediately give the developer some kind of a feedback if there are security issues, right? this has become a very popular approach to doing things. So let me give you an example of, and I'll show you a demo of this, right? So I have, let me open up my GitHub. So I have a source code repo, which is this, and I'm going to actually clone and download this. Just give me a second. I'm going to stop. I'm going to clone and download this. Oh, I think I do have it already. Great. So let me just show you. So in this case, as soon as I, the developer, make some change to the code, I want to be able to trigger some kind of a security scan. So what I've done, this is GitHub. I'm sure many of you have seen this. What I want to do is as soon as I commit some code to the repository or to my source repository, I want to be able to scan and give the developer some immediate feedback regarding this. So I'm going to just show you how this works. So I'm going to just close these pull requests and I'm going to merge this. I'm going to merge this and I'm going to quickly just give me a second. I have one more thing to do. I'm going to merge this as well. Yeah, this is done. Right. So this was a demo I just gave in AppSec California, so that's why you see that being typed up there. Anyway, so what I'm going to do is the developer is going to commit it to a particular branch called the test branch. Right. Now, as soon as the developer commits, we are going to trigger an automated set of events to help work this out. So let's see where this is. Show in terminal. Okay. Yeah, so just give me a second. So I'm just going to increase my resolution of my screen here. So that's documents, code, Python, functions. Now here, now we have 3 files, and I'm going to make a small change to one of these files. So I'm going to zap.py, and I'm just going to remove. So I made some change. So imagine that this is a developer writing some source code, making some change to a bunch of files. I'm also going to make a change to the requirements.txt file, right? So here what I'm going to do is I am going to remove this dependency. So what I've done here, just to explain to all of you and be clear, is I have made a change to a Python file, and I have made a change, which is the source file, which is my source code, and I have made a change to the requirements file, which is my libraries file. So if you look at the requirements file, it's essentially a list of all my third-party libraries that I'm using in this project. So what I want to do is as soon as any changes happen to either any Python file or this requirements file, I want to trigger some security scans. The first thing I want to do is scan the Python file for vulnerabilities, just like you saw in the previous demo, right? We scanned 4,000 lines of code. Now in this case, I'm only scanning one file. And if this undergoes any change, I'm also going to scan this with another tool that would help me identify security issues with all of these third-party libraries. So for instance, let's say I have a third-party library, this. I want to be able to identify security issues with this third-party library or this third-party library or this third-party library. So what are the publicly available security issues for those third-party libraries is something I want to identify immediately as soon as I check in code into my source code repository, right? So I'm going to do that now. I'm going to simulate how this works. So what I'm going to do is I'm going to commit this insecure commit, and I'm going to commit this to our source repository, and I'm going to push it to my test branch. Now what I'm going to do now is go back to GitHub, and I'm going to create something called a pull request. Now this is typically done whenever developers want to send this for review to a senior. So let's say junior developer has written this, wants to send it to review for a senior, then would create a pull request and say that, hey, I want to send test and I want to create a pull request. So please review all the changes in this. Now the idea here is we are not going to manually review anything. We are going to generate a completely automated review. No human is going to review this. It's going to be an automated review. So let's create a pull request. And as soon as I create this pull request, my cloud tools must start scanning this, and we should see some feedback coming up soon. Yeah, you see, immediately there is some new feedback coming that, hey, this file is vulnerable to XML attacks. This file is vulnerable to XML attacks. These three libraries, you see the two tools have been scanned. So two tools, you remember, I didn't do anything. I didn't review it. I did not actually manually do anything. Automatically, this was done through my automated program that is written every single time. So every single time a code is committed, I fire an event, and this event triggers a flow like this. It triggers all of these different flows on the cloud and comes back with these security findings immediately available to the developer. Now the developer sees, oh my God, this file line number 1 has this problem, I need to fix it. This file line number 28 has this problem, I need to fix it. This library is vulnerable to all of these things, I need to fix it. I need to change the library, I need to upgrade the library or do something, right? So one of the things that you will see here is the ability to scale and do things much faster, because the developer is getting immediate feedback on things that he or she is doing as part of the process, right? So that's something that you will see, which is a huge value add. Imagine being able to do this. If Microsoft had to do this 87,000 times a day, if they have to have manual people reviewing it, is almost impossible to do. So if you want to scale, automation is the name of the game. So we've written a small automation that would trigger, as soon as code is committed, it would trigger this particular flow, and it would run all of these different tasks and come back with and write it back to the original GitHub repository. So that's the beauty of using automation in these kind of workflows. This is used by some of the largest, so some of our clients are the largest e-commerce companies that use things like this to be able to scale their entire application delivery and security processes. Right. So I'm just going to continue with this. So this is an approach where as soon as the developer starts to commit and check in certain code into the repository, a certain set of activities are triggered that gives the developer immediate feedback on the security issues. This is the pull request thing, which is just an extension of what I already showed you. This is becoming very popular because a lot of tools today are giving you the option of doing this as part of their process. So if you're using GitHub or GitHub Enterprise or GitLab or some popular Git-based tool, you will see that a lot of this is possible automatically in many ways, right? This is something that you're seeing happen a lot. The other way that I really like to do a lot of static analysis is with Docker. Now, I don't know how many of you have heard of Docker or used Docker, but Docker is essentially a packaging technology that allows you to package your entire application in a container. Now, this container can be distributed to anyone, and once it's distributed, it works the same way on every single machine as it works on the developer's machine. So the developer can never give the excuse that, hey, it worked on my machine, it's not working on your machine anymore, because you have Docker, because the container makes sure that it is the same setup on every single machine it's deployed to. So a lot of times, security tools, you can use something like this to be able to trigger a lot of these security scans. So let us say you have new signatures or new things coming up, you can scan all of that with things like Docker or Docker-based processes. The other one is also called a commit hook. Now, this is an approach where as soon as the developer writes some code in the developer's machine itself, it triggers a certain type of scan. So as soon as the developer writes code, and before the developer can push it to the source repository, you can catch security issues and say, hey, developer, you have all of these security issues. Fix it before you push it to the source repository. Right now, this is also a very popular way of doing things. So let's show you a demo of this, and I'm just going to increase my screen size so that everybody can, or screen resolution that everyone can see. So I'm just going to use this. So I'm going to, now what I'm going to do is I'm going to, just give me a sec. Oh, sorry about that. I think I made a mistake. Yeah. So I'm going to just copy this. Now so every source repository, especially like Git, has something called commit hooks. Now a commit hook is like an event. It's triggered as soon as something happens. So as soon as the developer pushes code, it might trigger. You can configure it to trigger on different events, right? So in this case, as soon as the developer commits code, I will trigger an event, right? So it's again automated. Remember, all of this is completely automated. I'm just setting it up to show you how it works. Yeah. Oh, right. So this is done. So I'm going to be committing this file called maliciousfile.py. So let's look at this file and let's see what makes it so malicious. So we have our SAST tool, and I think it's a little slow because of the video as well. But let me just show you what it has. So we have some. Now this is a dangerous code that I've written. So this is some dangerous piece of code. So this code is actually called a deserialization flaw. Now, if somebody is able to exploit this, they're going to be able to completely control my application, completely compromise my entire server environment because of this code, right? So I'm going to be committing this code, and as soon as I commit this code, my tool should tell me that, hey boss, don't commit this code because it's vulnerable to this. So let's show you how that works. I'm going to commit the code now. Just give me a second. I'm going to initiate the commands to commit the code. Yeah, it's a little slow. You must bear with me. The environment, especially since I'm doing this on video, is going to be a little slow. So I'm going to commit that now. One second. I think I need to do one more process. Yeah, here we are. Yeah, and the last one, I'm going to commit the code. Now you see, as soon as I committed the code, it scanned all of the stuff in that particular commit and said, hey, you found, if you use this particular YAML.load call, you could have a remote code execution. Somebody can potentially compromise your entire application. So you see that the developer is immediately able to get feedback on what he or she is doing based on this particular type of approach. So the developer is automatically made more visible to security. One of the biggest problems with a lot of application security issues is that the developers are not aware, and the problems are not made as visible as you would like to the developers, right? So by making problems more visible through an automated process, the developer immediately is able to identify and then start to fix all of these things, making sure that vulnerable code never makes its way to the application in production. It's immediately checked within the environment itself, right? So this is a demo of what I was talking about. So this is called a commit hook. Again, this is also an automated approach, a fully automated approach. Now, the other thing that I'm going to be talking about is source composition analysis. And this is something that I said is extremely important for our application. Now, source composition analysis is the practice of identifying security issues with our third-party libraries. Now, all of us use third-party libraries for our code, right? We use third-party libraries for doing what we do on a daily basis. To write our applications, we use a ton of third-party libraries. Now, when we use these third-party libraries, remember that these third-party libraries could have security flaws. And when these third-party libraries have security flaws, it could result in a massive impact to our application, right? Now, I don't know how many of you remember the Equifax breach from 2017. Now, Equifax breach led to about 150 million social security numbers and PII data sets of the US being compromised, right? Now, the vulnerability that caused that particular flaw was a flaw with the Java framework that they were using that had not been patched. It had not been patched. One of the third-party libraries that they were using had not been patched. As a result, the attackers detected that. They were able to launch an attack against that, compromise the database, and were able to completely exfiltrate 150 million plus records from Equifax's databases, right? So that was only because there was a library that was a vulnerable library that Equifax was using and had not patched at the time. So 24% of application security breaches have been caused by this category of flaws, which is your third-party components. And this, if you see the other statistics, you'll be much more alarmed. Node.js applications, 97% of an average Node application is third-party code. This is from their Node Package Manager project itself, which is the Apex Package Manager product. So imagine that out of 100% of your application's code base, only 3% is your code and 97% is all these third-party libraries. That is crazy, right? That's a huge percentage of third-party libraries. And according to Synopsys Black Duck, 96% of applications have more than 257 components, right? 257 components or more, which means that there are 257 third-party libraries in 96% of applications that were part of this particular survey. So this is huge. The numbers are massive, especially when it comes to large applications. You have lots of dependencies, lots of third-party libraries that can cause a lot of security problems for your application, right? So this is something that is very, very bad. So what we need to do is do something called source composition analysis. Now, source composition analysis is essentially a practice of identifying security flaws against these third-party libraries. Now, these third-party libraries, all of these flaws are in a database called the CVE database, or the Common Vulnerabilities and Exposures database, right? Now, this is a free, available database across the globe. So if you look at the CVE database, you will find a bunch of entries related to this. I'm just going to go to one of the popular sites, which is CVE details. Now you find security flaws for all third-party components, or not all, but many of them in this database, right? So for instance, if you see for 2020, I think we should have some flaws for 2020 vulnerabilities by date. You will see that year 2020. Let's look at the flaws for January. Oh, nothing, clearly. That's weird. There's usually always something. Maybe they've not filed it yet. Let's look at it for December 2019. Whoa, this is weird. So you'll see that for every month or so, they file these security flaws, and each security flaw has a CVE value assigned to it. So in this case, CVE 2019 15842 happens to be some PDF library for WordPress that has cross-site scripting or what have you. Right? There are so many different libraries where security researchers keep reporting vulnerabilities that make its way to this particular database. And this database maintains like a master list of those particular flaws. Now, when you're doing source composition analysis, what you want to do is tools to be able to identify all of these things. So finding vulnerabilities in all your libraries, all your third-party libraries that you're using, managing licenses, right? A lot of times these licenses may be something that you're not allowed to use. So a lot of organizations may not allow you to use GNU or GPL or something like that, all of these license types, or outdated components, right? So things like, hey, this component is from 2010, but you are in 2020, why are you still using this component? So that's why this helps you identify those outdated components. That's something that SCA helps you to do. So SCA tools help you do all of these things. It helps you identify age, it helps you identify vulnerabilities, it helps you identify risk, it helps you identify the type of component and the function and so on and so forth, right? Now this, let me just show you a demo of this and we can see how it works. So one of the tools I'm going to be demoing now is an open source tool called the OWASP dependency track. Now this is a very interesting tool. This is a free tool, open source, like I said. This is a very nice tool that you can use. I would recommend you look at this or some other tool. You're probably, if your organization is already doing this, that's great. But if you're not, then it's something that you should consider as part of your process. So one of the things I'm going to be looking at quickly is OWASP dependency track, and we'll Let me see if I can show you a demo of this without causing too much delay. Oh, I don't think so. Let me just pull up the, actually, let me show you a demo of another tool which is much lighter. This takes a while to set up. I thought I'd set it up, but I'd not. So I'm going to, this is a tool called NPM Audit for Node.js. So for instance, what this is going to do is for a Node.js project that you have, it will scan all the third-party dependencies and come out with a list of findings. So I'm going to just scan this project. No. Oops, sorry about that. Now, what this is going to do is that most of the projects that you're working on have an inventory file, right? You have a declared file of what are the different libraries that you're using. In Node.js, that file is called the package.json, right? So if you look at the package.json, it tells you all of the dependencies that you are using in your project, right? So what this does is that it gives you, it looks at all of these dependencies and then starts to scan these dependencies for security issues and tells you what are the different vulnerabilities in those dependencies. So if I run npm audit, you will see that it's going to come up with a bunch of findings. You see that so it's found 21 vulnerabilities, 4 low, 9 moderate, 6 high, and 2 critical. Wow. So we found a bunch of security issues with our npm with our libraries that we're working with. One of the cool things about such tools is that it not only finds security issues in the library that we're using, but it finds security issues in nested libraries. So just to understand what a nested library is, see, we are using a library called Express. Now, Express is using a library called Send, and Send is using a library called Mime, and that's where the vulnerability is. So since even though you're just using this top level library, you are still affected by this flaw because 3 layers deep, you have this library which has this vulnerability. Or in this case, you see that this again is that particular flaw with MIME for serve static and send. So you'll see that it's not only able to find security issues with top level libraries, it's also able to find security issues with lower nested libraries in your application. So you can see that it's a pretty, so you need to do things like this in order to be able to identify it. And like you saw in the previous example, if you can do it as an automated process like this, the developer immediately gets feedback. So in this case, we ran it against a Python tool and it said that, hey, this library called Django is vulnerable to these security issues and so on. So you have all of these possibilities with source composition analysis. That's something that you can do with source composition analysis. Now, the next area I'm going to look at is probably the most challenging area from a security perspective, right? This is so far we've looked at static analysis, we've looked at source composition analysis, we've looked at some automation approaches to doing this. But the next one is a really complicated, one of those highly problematic automation projects. This is essentially scanning or vulnerability scanning applications with dynamic application security test tools, right? So this is essentially what we're talking about. So I'm sure some of you in the audience have used Burp or Zap or some of these tools to scan your applications for vulnerabilities, right? Or you might have used AppScan or something else. You might have used AppScan, you might have used AppSpider, you might have used Fortify, you might have used multiple tools to do this. Now, this is essentially when you have deployed your application to an environment and you want to be able to scan that application to identify runtime flaws. Now remember, source code, you can identify certain types of flaws, libraries, you can identify certain types of flaws, but there are certain types of flaws that cannot be identified by both these things, and that you can identify either when a human being tests it or when a tool fires payloads at it like an external hacker and is able to identify these security flaws. Now, this is called DAST, or Dynamic Application Security Testing. Now, DAST by nature is a very human intensive process, right? which is why it has been traditionally hard to automate. DAST has largely been a human-intensive process, which is what has made it much harder to automate. Now, one of the big challenges is that with DAST, if you do not provide certain, so I don't know how many of you have seen this, with DAST, if you do not, if you want to automate, it will just essentially scan the outside pages of your application. Now, if you want to make it scan the internal pages of your application in a completely automated way, DAST has a lot of difficulty doing that, because remember, usually human beings do this effort. So typically I am sitting behind at my DAST tool and then proxying through that DAST tool and then identifying security issues as a human tester or a human pen tester or a vulnerability scanner. Whereas with a completely automated process, this is much harder to do because, hey, there's no human being. You have to run this in a completely automated way every single time. So how do we do that? So let's look at some approaches. And we now go to our to a completely different team to solve this problem, which is our QA team or test automation team. Now, I'm sure many of you who are in the room probably have QA teams or work with QA teams in your own organization, right? So you might have seen, you might be working with your QA teams that do integration tests, that do end-to-end tests and all of these things, right? So you'll be thinking, you're probably thinking, hey, how does a QA team feature in security? How do they matter? Aren't they a QA team? Why does their work feature in security? Now, what a QA team typically does is essentially write test automation, right? A QA team essentially writes test automation. So what they would do, so imagine that I am a airline booking site. So imagine, just take for example that I am makemytrip.com, right? I'm sure some of you have heard of makemytrip.com. Now, makemytrip.com is a very popular web application. Now, their QA teams, what they would do is essentially create test automation that would mimic a user's behavior on makemytrip.com. So what they would do, they would log in, the automation script would log in as the user, then it would perform an air ticket booking. It would look for this flight, this date to this date, and then it would find the results, it would click a result, and then it would buy the ticket. Essentially, this is done to make sure that there are no bugs in the application, right? There are no bugs in the application. That is why you do test automation, right? So you write test automation so that you don't have to have a manual tester always running things manually. You can have this test automation script that walks through the entire application and identifies all of these security issues. Not security, sorry, functionality issues. Now, one of the things you can do with this is to take that test automation script and proxy all of that test automation through your security scanners, right? So what we're going to do is take all of these scripts. Let me just go back to that slide. Take all of your test automation scripts like Selenium or Appium or any of these scripts, proxy that through automation tools like Zap or vulnerability scanners like Zap or Burp or Arachne or whatever, and then scan your application that way. So what it would do is that even as an authenticated or a fully as a fully authenticated and authorized user, you are scanning the application and you're not just scanning it knee deep or something like that. You're essentially going full in depth and scanning that application to identify those security issues. And that's one of the big benefits of using test automation. So which means that your QA team is now your friend, right? As a security team, you should be friends with your QA team and make sure that you can leverage their work. They're already doing this work. So one of the things you should do is say, hey, QA folks, give me your test automation scripts or give me a copy of your test automation scripts. I'm going to proxy it through my security tools and use that for security testing, which is great, right? Now you're reusing another team's work, which makes your job a whole lot easier, right? In fact, what we do is we run a lot of this completely automated as part of our pen testing services, and you see that we save at least 80 to 90% of time that would have otherwise taken in subsequent pen tests when a client asks us to do this. So it makes it a lot easier, a lot cheaper, a lot faster for a lot of our clients when we want to run automation. So automation makes sure that you can do all of these things in a much more comprehensive way. So you have several test automation tools that can do this. Selenium, I'm sure some of you have heard of Selenium in the room. If you haven't, it's essentially a browser automation tool. So it opens up a browser. It essentially tries to simulate what a user does on your application through the browser, right? So it has Chrome, it works with multiple browsers, and all of the other frameworks also do similar things, and they build off of Selenium. Google has recently introduced a new framework called Puppeteer, which also does pretty much the same thing, but only for Google Chrome. Selenium works for all browsers. In fact, it works for Mozilla, it works for IE, it works for Safari, it works for Chrome, works for pretty much anything that you can think of. You also, now today we are not only writing browser-based web applications, we also do a lot of RESTful API, right? We write a lot of APIs, especially in our modern application stack. A lot of what we write, a lot of applications that we build are API-based applications. So one of the things that you can do with this approach is use REST API automation tools like these to be able to automate your test automation and then pass it through security scanning to be able to perform the actual scan. So that's one of the cool things that you can do with test automation. So I'm going to quickly show you a demo that will talk about this. And just give me a second. So I'm going to be using a framework called Selenium with Zap. How many of you, I'm not sure if anyone can respond, but if you've used Zap, Zap is a very popular tool that helps you do this, open source tool, and it helps you do this. So I'm just going to show you this demo. Just give me a second. Oops. Let me just start it up. Just give me 2 minutes to start it up. Looks like the server has gone down. In the meantime, if there are any questions, I'll be happy to take. Of course, we can always wait till the end, but if you have any questions on what we have discussed so far while this is coming up, I'll be happy to take those questions. I'm not sure, is there a chat option or something?
The chat box is there. I will take the questions and case send question. Thank you, Abhay.
Yeah. I'm just waiting for the server to come up. Yeah.
So there is one question that what about data vulnerability?
I'm sorry?
What about database vulnerability?
Database vulnerabilities. Okay, now database vulnerabilities typically come into your vulnerability scanning that is done as part of the infrastructure vulnerability scanning, right? So let's say you're running a vulnerable version of Oracle or running a vulnerable version of MySQL. That comes in at the last stage of your DevSecOps pipeline, right? Before deployment, just before you deploy, you're running a bunch of security checks against that. And you have tools that do this, right? Stuff like Nessus can do this, or many tools can do this. You can put that in an automated way or use that in an automated pipeline to be able to trigger those scans and identify those security issues. So yeah, that's something that you can do as well.
Okay.
I'm just waiting for this to come up. Yeah.
How does apply to bot application implementation? For every change, you are dependent on vendor. How does DevOps apply to bot application implementation? For every change, you are dependent on vendor.
Oh, yeah, you're talking about a bought application, a purchased application, right? Yeah. So in that case, what you will have to do is probably so it depends on your contracts with the vendor. So some vendors some vendors require, some vendors allow you to externally test it, may not give you access to the source code. So you may not be able to do the source code stuff, but you need to probably put it into their contracts to do all of these things, or make sure that you have artifacts for all of these things. Second, whenever you are, whenever you are doing this externally, so let's say you're doing a pen test or something like that of the vendor application, that's when you can use automation to be able to run some of these tools in a pipeline. So it depends. So it really depends upon the kind of agreements you have with the vendor. So if it violates the vendor's agreements, obviously it won't work. But if you include some of these clauses in that agreement, that's when you can have this work as well. Right, so actually this has come up, so I'm going to quickly take questions later. I'll just finish up this demo and show you how this works.
No problem.
Yeah, so we can get back to questions after the session. So in this, what we are doing is I'm going to show you how to automate a full application. Now, so this is going to run a vulnerability scan against the application after authenticating and authorizing to that application, and it's going to publish this in a completely automated way. So we're going to start our application, which is called WeCare, which is like a intentionally vulnerable healthcare application. So imagine that this is run in a hospital or run as part of a healthcare group somewhere. This is a intentionally vulnerable healthcare application. It's just going to take a little bit of time to start. Just give it a few seconds. And then, so what we're going to do is we're going to run a test automation script, and we're going to proxy this test automation script through our security scanning tool. And once the test automation is done, we will kick off our security scanning tool in a completely automated way, and then produce some results that are going to appear on screen. That's what this script is going to do. It's a completely automated workflow of what we are planning to do. So let me see if it's running. Yeah, it's running. So this is running on port 9000. So I'm just going to show you the app that we are. So this is the app that we're going to be testing. So this is an app that we have. You can see here. It's called WeCare, and this has a bunch of. So this is intentionally vulnerable. It has a bunch of flaws, But these flaws you can't identify by just randomly testing the application, right? Because you need to log in, you need to access as the user, you need to access certain functionality. Only then those vulnerabilities are identified. So it won't just identify flaws without having that authenticated context. So what we are going to do is, we are going to run our automation. So what we're going to do here is we have a automation script here called walkthrough.py, and this, what it's going to do is it's going to open up a browser, and I'll just explain the script as we go along. So it's going to open up a Firefox browser, and you won't see this open up because it is a headless browser. So when you're running it in an automated pipeline, you can't see the browser, right? You're running in a server environment, so you can't see a visual display. So what you're going to do is you're going to open it up as a headless browser. Headless browser essentially means that it's going to open up as a daemon mode. Then it is going to proxy all of my traffic through ZAP, which is running on port 8090. All of the test automation is going to be proxied through ZAP. And once this is done, it is going to walk the application. So it's going to go to this window. You can see that it opens up a window. You go to the login URL, and then you enter the username, password. You authenticate to the application, and then you go to the next page. You enter some data here. You go to this page. You enter some data. So it's essentially walking through the application, right? So you go to a search parameter. You enter something here. You go to the test parameter, you enter something here. And once you're done with all of this, you kick off a security scan. So all of this is done as an automation process. So it runs the security scan, completely runs that particular security scan. And once it's done running that security scan, it writes all the results to the table on screen, and it shuts down the security scan. So you can see that it's a completely automated script that is able to achieve all of these things and come with results once it's done. So I'm going to run this. I'm just going to start my ZAP tool. So ZAP is a vulnerability scanner, which is, I think it's called, this is again from OWASP. You can, if you're not using this, you should use it. It's an awesome scanner. I think OWASP ZAP. Let me see. Pull up the, yeah, zapproxy.org. So I think I got it wrong. Yeah, so this is a free open source scanner that you can use. It's got great automation capability. It's a very powerful tool that you can use. I really like using this personally myself as well. So yeah, so ZAP is listening on port 8090. So if I do, let's start you'll see that we have our application running on port 9000. We have our security scanner running on port 8090. Okay, so now what we're going to do is we are going to run our walkthrough script. Okay, we're going to run our walkthrough script. So what this is going to do is going to open up a Firefox browser. Again, you'll not see the Firefox browser, but you'll have to take my word for it that it's opening up a Firefox browser. Then it's going to access this particular URL on port 9000, and then it is going to walk the rest of the application. It's going to check the login URL. It's going to authenticate as this user, this password, and then it's going to walk the entire application. I don't know why it's, yeah, then it's going to go to dashboard use. What it's doing now, I'm not sure if you're able to understand. What it's doing now is essentially walking the application like a user would. So I'm going to go to login as this particular user, and then I'm going to go to dashboard, and I'm going to go to another screen. So it's essentially doing what a user would do in a completely automated workflow, right? So it's going to dashboard, it's going to this, it's going to, so you see it's in dashboard, then it's going to go to a test URL, it's going to enter some data in here, it's going to, so it's doing what a user would do against the application. And this is what your QA teams do. That's what they do, right? Day in and day out, they write automation scripts like this. And that's really what the beauty of this is. You're leveraging their work to be able to also get another benefit out of their work, which is security testing. So once this is done walking through the entire application, our ZAP scan is going to get triggered. And remember, now since we are proxying all of this through ZAP, all of this authenticated context, CSRF tokens, all of that stuff is with ZAP, so that ZAP can perform a much more penetrating scan against this application to uncover more security issues in a completely automated way. You can see that all of this is happening completely automated. There is no manual intervention to any of these processes at all. So it's going to be done walking the app. Now you can see that the scan started, right? So it started the scan. Scan progress is currently 0%, but as you go along, you'll see that the scan progress is going to steadily increase at 6%, and over time, it's going to reach that 100% mark. I'm just going to move on to the next subject because this might take a little bit more time. I don't want you to sit looking at a screen waiting for this to complete. So the idea here is that we were able to use a completely automated test automation script along with our scanner workflow to be able to combine the two to provide a very, very powerful approach to performing security testing through complete 100% security automation. So we have solutions for SAST. We've looked at source composition. We have solutions for DAST. We have all of these things happening in a completely automated way. And that's, you can see that the scan progress is currently at 53. And once this is done, you will see that it's going to write a bunch of results on screen. Now, one of the challenges that you will come across when you do this, when you start doing this, is that you will get a lot of results, right? Especially if you do this continuously, you will get a lot of results. You have different tools that are going to give you a lot of results for different things. If you don't have a good way of managing it, then it tends to become a huge amount of information overload, which you may not be able to deal with. So imagine that every day you're triggering SAST scan, DAST scan, source composition scans for, let's say, 50 applications. And 50 applications is not that many. In fact, I was working with you can see that it's written all of the security findings here on screen. You can see that it's found a bunch of security issues. It's written it on screen here, and that's it. So you can see that through a completely automated workflow, we were able to trigger a complete security dynamic scan. So that's the idea behind using something like this. So just coming back to our slide deck. So one of the things you're going to see, especially with security automation, is that over time you're going to have overload of information, right? You have so many different tools doing so many different things. It gets very, very complicated. It gets very, very difficult to work with because you have so many results coming back. So you need to have a much better approach to doing this. So first of all, one of the things you should definitely look at is some kind of vulnerability management approach, a vulnerability management tool that helps you kind of centralize all of these findings and vulnerabilities that you have. The second thing you should do is try and integrate with the developer's workflow, right? Now, let's say in your organization, you're using some kind of bug tracking tool or Jira or some other tool. Now, very popular tool is Jira. I don't know how many of you have heard of it. I don't know whether it's popular in Oman or anything, but Jira is an extremely popular tool, especially where we work, mostly America, Europe. This is an extremely popular tool. You do have different tools, of course. You have Rally, you have Jira, you have GitHub, you have Microsoft VSTS. Now, all of these tools achieve the same purpose, which is essentially allow developers to allow tickets to be raised on developers that they need to fix, right? So service tickets, bug tickets, so on and so forth, right? So if you introduce security into this workflow, what it will do is that the developer will be much more enthused to actually fix it, because developers understand tickets, right? They understand bugs. So, and a security flaw is nothing but a bug. It's not some weird dark magic or something like that. A security flaw is nothing but a bug. It's just a different type of bug. It's just the same, but in a sense, it's a bug. So if you want them to fix bugs, raise tickets, and you do have automated tools like the one I'm going to show you, which can help you do that. So the next demo that I want to show is our tool called Orchestron. We do have an open source version of this tool, so I highly encourage you to look at that as well. So I'm going to be showing you this particular tool and show you how it works with Orchestron. And I'm going to just give me a second. I'm going to open up the instructions for this. Yeah. So yeah. So Orchestron is a tool that we built just for this purpose. In fact, that was the main focus of ours, was to build out something that would help our companies, handle this kind of security requirement or this kind of vulnerabilities that you could see. Just give me a sec. I think I've got the wrong port, perhaps. Oh, root Orchestron. Okay. Now, just give me a sec. All of these machines are a little slow because of the GoTo meeting. I think it has kind of hijacked my internet connection. So Orchestron, yeah. And I'm just going to, so what I'm going to do is, so I'll just log in and show you how that works. Oh, it's in this URI. Okay, great, perfect. So we've deployed Orchestron here just to give you an idea. Now, Orchestron is like I said, it has both a community and enterprise variant. And the community variant has some features, but the enterprise one also has some features plus some other features. I'm not going to get into these specific features now, but what it does is that it helps you essentially correlate vulnerabilities, right? So it helps you kind of get all of the information about vulnerabilities. So let's say you have vulnerabilities coming from different sources, you should be able to use something like this. You do have other tools as well. Of course, you have something like Defect Dojo from OWASP. You have different tools that can help you do this. But Orchestron, one of the things that we've done is provided a lot of support for automation. So you can just push results from a simple automated workflow like this. So what I'm going to do is I'm just going to quickly push the result. So just from a simple curl request, I'm going to push a result to Orchestron. Now you can see what is going to happen. This is a simple curl request that I'm going to use and push it. So this is going to make an HTTP request to Orchestron. I'm going to push the vulnerabilities to Orchestron. So this is going to push this file, which has all the vulnerabilities for a particular tool. And when I push this, you'll see that it pushed it successfully. And now if I repopulate Orchestron, you will see that there are new findings. So it works very well for automated workflows, right? So you see, if you go into the open workflows, you'll see that, hey, Node.js scan, you have this particular flaw. Now you go into that particular flaw, you can actually get all of the information about, hey, where was this particular flaw, which vulnerable code, you get all of that information right then and there. So this helps you kind of make sense of the madness, right? You have so much data coming in from all of these tools, you need a much more structured way of managing it. And most of us use Excel sheets or PDFs, but when you're doing DevSecOps, you can't do that anymore. You need something a lot more robust that can handle it. So it gives you all of this information about, and it tells you a little bit of information about good code, bad code, and so on. Now I'm going to show you a completely automated flow where we're going to trigger a full pipeline and push all the results to Orchestron. That's what we're going to do in our next demo. Yeah, root robot Orchestron. Now here we're going to trigger a, so let me just show you what we're doing here. So here we are going to create an application. Now Orchestron is completely API, so we're going to create an application. We're going to run a SAST, we're going to run static analysis, we're going to run both these things and push all of these results to Orchestron at one shot. So a complete pipeline we're going to use and push all of these results into Orchestron. Right, so I'm just going to use that and I'm going to run this command, which is a pretty simple command. So this is a test automation script, right? So this runs a full automation pipeline of sorts. Oh, sorry about that. Just one second, please. Oh, I think I need to do this. Yeah, sorry. I forgot to add this step. Robot. Okay. So this is going to push. So you see that it's running npm audit, which is a source composition analysis tool. So you see that all of this was done, pushed into Orchestron. And now if I go into Orchestron, you will see that there are more vulnerabilities now. So you'll see that there are 11 vulnerabilities. Previously there were 3, but now since I've added a new application and pushed that, so you see that a new set of vulnerabilities has been opened. So new 11 vulnerabilities has been identified, and you will see that you'll see all of these flaws being identified as well. So if you push results from any tool, typically you should be able to parse it with a tool like Orchestron. So it helps you manage the whole thing. It gives you a bunch of reports like date range and so on and so forth. So it gives you, so how many times this vulnerability was reopened, or what is the vulnerability code that it has, what are the consequences of this. It gives you examples of how it works, why it works the way it works. So let me just go into a report where I can actually give you some. Yeah, so let's look at SQL injection, right? SQL injection, very popular flaw. So you'll see that this line of code was vulnerable to SQL injection, and you see that it's right. So this line of code, line number, it actually gives you all of that information and gives you the line of code that is vulnerable to SQL injection. So it helps you manage the results in a much more comprehensive way, rather than having a rather than being overwhelmed by all the information you get. One of the big challenges with DevSecOps as a strategy is that it's great, automation is great, but if you don't know what to do with that automation, that's when it becomes very complicated, right? So with a more concerted strategy with good vulnerability management and workflows like Jira and so on, you should be able to actually get a lot more control over your application security process and DevSecOps process to be able to actually get control and to be able to deliver visibility to the SDL in terms of security. So in conclusion, I'm gonna be closing now. One of the things that you should understand about DevSecOps is that it's a lot of this is about culture, right? Your organization's culture makes a big difference to a success or failure of a DevSecOps implementation. Automation is definitely the way to go if you are looking at your own organization. If you want to build out a much more robust process that does not require human intervention all the time, then automation is definitely a way to go. You should be looking at automation. These are just some of the ways that you can do it, but of course there are many other ways, many other approaches. Especially if you're going to the cloud, there are thousands of approaches that you can do this with, so it makes it a lot more powerful to do this with those approaches. I would highly recommend, I'm going to share this presentation anyway, but just go through this presentation. If you have any questions, hit me up on Twitter or LinkedIn. Typically, I am on these two channels. My Twitter is here. You can see at the bottom of the screen if you can follow. I do post a lot of live coding videos. We are also launching an online training product on all of this stuff in April. So if you are interested, you should look at that. I do a lot of live coding on YouTube and so on, so you should look at that if you're interested. Yeah, so DevSecOps is important. Definitely keep that in mind. But again, don't try and do it big bang. Try and do it slowly. Try and build up to it, and try and collaborate with your engineering teams rather than being a security silo by yourself or an audit silo by yourself. So with that, I come to the end of my presentation. Thank you very much. I hope it was useful. Thanks for being a receptive audience. I thank you for the questions you gave me, and I'm hoping to take a few more questions now as well.
Yes, thank you for the wonderful webinar. And I have requested our friends to type their questions through mail.com. And let us wait for 2 more minutes and see whether any questions are popping out.
Sure.
Tim, you can post questions through the mail.com with code 473119. We'll wait for 3 minutes, then we will move on to the next step.
Oh, I didn't know about this. This is something for questions, is it?
Yeah, with the questions.
Oh, okay. This is nice. So ISACA Muscat has really modernized the way of handling all of this. Very nice.
Oh, thank you for your compliments. Yes. I hope you are seeing. Started coming in up.
Yeah. So what would be your suggestions to implement DevSecOps in an environment where COTS is adopted? Yes, this is a very common query, especially from the Middle East. This is a very standard query. Now, one of the things that with COTS, you do have certain opportunity. It depends. See, with COTS, you really have a couple of things you should consider. One is, first of all, again, like I said in the previous question, the agreement with the vendor, right? Now, in some cases, especially in the US, what they've started to do is making a lot of security-based artifacts and disclosures required from the vendor. And this is becoming an increasingly popular practice. So the agreements with the vendor, I would say, are extremely important. But let us say you do have some agreements, but you don't have source code, you should at least be able to have them use some of your automation process. So let's say they already have test automation, then you should have them at least run this as part of their process, insist that they do it, insist that they do static analysis and provide you with artifacts and what kind of processes they're using. I think that would be the bigger focus rather than you being able to do something, unless you have an agreement that allows you to do that. So it really comes down to the agreements. It's not as simple as, hey, you can do this or not do this. It really comes down to the kind of agreements you have. So yeah, that's one of the challenges with COTS, but I've seen that especially in US and Europe, we are seeing a lot more accountability being tagged to the vendor today than ever before. So I would definitely recommend you look at those models as well. Anything else?
Yes, come. Another question.
Yeah, has it changed? I'm not able to see any change in the screen.
Oh, it did change.
Oh, yeah. Okay. Is there a defined standard for frequency of deployment of patches based on severity of vulnerability? Idea is to use it as a benchmark to define our own standard. Um, it depends. Again, now there is no real benchmark unless you are in a regulated industry. So let's say you are not regulated or at least compliance driven industry. So let's say you need to be PCI compliant, or let's say FISMA compliant or FINRA compliant or whatever it is. Then you would typically have some defined standard. But usually what I've seen organizations do is to define their own patch standard based on either vendor driven metrics. So for instance, Microsoft Patch Tuesday plus 7 days, or vendor patch cycle plus 7 days for critical, maybe 30 days for medium or something like that. So it's not always clear. It depends on a lot of things. So for instance, let me give you an example. So we use containers for a lot of things, right? So our deployments are very simple. It takes literally 2 minutes to redeploy something. It takes very little time to redeploy something and push out a new version. But not all environments are like that. Most environments are still heavily dependent on downtime. You need to have change tickets, you need to do downtime. So it really depends on the speed of deployment in the environment, and that's really something you have to take into account, or based on the compliance standards that you need to adhere to. So let's say there is a national security law in Oman that requires you to have patches critical security patches to be rolled out within a month of release. Then maybe you have to follow that. I don't know about. I'm just alluding to some example, but it may not be real. But what I'm trying to say is that you'd have such things in some compliance standards like that. How reliable is the CVE database? This is a very good question. CVE database is reliable, I would say, to 60%. Now the problem, and that number is a little appalling, I know. The reason for that is, CVE is essentially a compendium of vulnerabilities across multiple products, multiple services, thousands and thousands of products, thousands and thousands of services. Now, there are lots of things that slip up. So for instance, if you see 2020, they've not even released any new CV entries, which means that it takes some time to even get your entry into the CVE. So I have put out a couple of CVEs myself, and it took 6 months, 8 months to release those CVEs itself. So it becomes a little complicated in terms of time. And today what we are seeing is that a lot of languages and platforms like Node or Python or Rust, or even I think .NET, and some of these folks, they're creating their own databases. So to make sure that it's faster than CVE and much more quicker for people to access than CVE, they're creating their own databases, which is becoming a lot more. So yes, CVE is reliable, but I wouldn't exclusively rely on that. I would probably look at tools that can pull from other databases as well. Is DevOps better than Agile? It's not really. It's like comparing apples and a burger maybe. So it's not really the same thing. DevOps is essentially, Agile is a manifesto, right? It's more an approach to doing things. So DevOps is really more process of collaborating between Dev and Ops, leading to more automation. So DevOps helps Agile, but DevOps not necessarily better. Can DevSecOps help you innovate in cybersecurity? Of course, it can, absolutely. In fact, by automation, you can really innovate how you're finding flaws, how you're fixing flaws, how early you're finding flaws, how you're modeling risks. Yes, of course, it can help you innovate quite a bit. Any other questions?
This one last question. What is the training path you recommend for DevOps for the beginner?
Right. Yeah, this is so this is a good question. See, with DevSecOps, one of the things, I'm going to give you a slightly generic answer and then a specific answer. The generic answer being, I've seen that most security professionals, they start off learning security first, which is wrong. We should start learning the technologies first, because if you learn technology, you can learn the security aspect of that technology pretty quickly. But if you don't know the technology, then it's very hard to pick up the security quite effectively. You'll know certain aspects of it, of course, but you may not be able to pick it up all that comprehensively. So that is my first, like a more generic recommendation. But a more specific recommendation for DevSecOps would be definitely look at how application development is done. Maybe look at Jenkins, look at how application delivery is done. Take some existing projects and deploy them in a continuous integration server like Jenkins. You do have some Jenkins courses and all of that stuff. Learn a little bit about containers. If you can learn how to code, that's great, because that will help you a lot. So yeah, I would start there and then get into the SecOps part of it.
Thank you, Abhay. Thank you for taking us through the beginning and the definition and the definition of this. I hope that our participants enjoy this session. It's the first of us in our chapter, and we are very happy that it has been delivered to you, Guru, in this DevOps. And now, as a customary, we would like to give a formal word of thanks, and I request programs director to give the word of thanks. Say, please come in.
Hello, am I audible?
You are
Yes.
audible. You can continue.
Hello?
Yes.
You are audible.
Yes. Abhay, thank you so much for such a wonderful session. It has enlightened us into various fields of, taking us through from history to the modern day of coding, and also bringing in the security features, how exactly a developer should think. And I think right now the more of a need is the mindset change from a lot of coders, that they should also start thinking about security when they are coding in their code for various applications. And in a nutshell, you had explained pretty well that how we can do that and use a lot of automation tools and identifying the vulnerability. Thank you so much. And I also thank ISACA Muscat to organize such a wonderful event, and the board, and also members, those who took out time to attend. And I hope that we will have such wonderful sessions from you, okay, in future, inshallah. More interesting things that you do, and some training session as well. Thanks a lot.
Thank you very much. Thank you for the Sakama.
Thanks a lot.
Yeah.
We had around 2 members in this session. I hope all enjoy. Thank you, Abhay. We will get in touch with you.
Yeah, thank you. Thank you very much. Good evening.
Thanks, Abhay. We'll get in touch with you again for more sessions of this kind.
Thank you.
Thank you very much.
Thanks.
Best wishes to your company.
Thank you.
Bye. Thank you all participants. Now we will close the session. Thanks for joining us for this webinar. Let us have more webinars in the coming months. Thank you very much. Have a good night.
Thank you,
Bye
sir.
bye.
Thank you. You too. Take care.
Take care.